Thank you. So good afternoon, everybody. It is a great pleasure to speak to you today and to see you all. So tonight I will be talking about Çatalhöyük and socio-material networks, and I will illustrate my recently completed doctoral dissertation. So now that you can hear me well, I'm going to start. So why using networks at Çatalhöyük? Which are the aims I try to achieve and question I try to address with this study? This research investigates the way large Neolithic aggregate communities formed and the way they were internally structured. It explored the social mechanism that developed within these dense communities and the manner these mechanisms enabled them to flourish and endure for generations seemingly without any evident administrative communal institution or clear hierarchical arrangement of power. It additionally addresses the social geography of this large agglomeration and diachronic variation in their social and economic structure. How did these large Neolithic communities form and how did they construct their identities and promote social cohesion? These issues are central to the understanding of the long Neolithic transition. This study aims to contribute to these issues using the site of Çatalhöyük as a case study and by employing concepts and formal analytical methods borrowed from network science. So I will get into the details of the methodology later, but for the moment I will say that for this research, network analysis applied to a complex data set formed by a selection of material cultural items excavated by the Çatalhöyük Research Project during its 25 years of research. This synthetic data set is used as a means for mapping pattern of similarities and differences between buildings at the site. The house in its material form is therefore the smallest analytical unit employed in the analysis, and material cultural similarities are utilized here to highlight possible links, relations of affiliation, belonging, or social cooperation between these entities. Additionally, my research participates in the conversation regarding the application of network concept and formal network analytical techniques to archaeological data and aims to contribute to the increasingly large body of research focused on modeling social interaction through the mediating role of material culture. So these are some examples of other studies that use archaeological materials and network science. I will now move to very briefly introduce the site of Çatalhöyük. So Çatalhöyük is a large double-tile site located in the southern part of the Konya Basin, which is a clay-rich former lake bed. During its lifetime, the settlement at Çatalhöyük spread over 2 mounds. The 13.3 hectare east mound that represents the core Neolithic occupation of the area, and the west mound that accommodated the relocation of the community during the early Chalcolithic. For the purpose of this research, I focus on the east mound, which is the place where the bulk of the Çatalhöyük Research Project research took place. So here you can see the main excavation area, the south area that was started by Mellards in the 60s and continued by Hodder in the 90s and later, and the north area that was opened by the CRP. The East Mound occupation dates between 7,100 and 6,000 BC. Based on our current knowledge, Çatalhöyük community flourished throughout the ceramic Neolithic with some degree of stability and continuity. The occupation of the East Mound is characterized by sequences of mud brick building constructed one on top of the other at intervals separated by external spaces, such as middens and panning yards. Çatalhöyük shows no sign of deliberate planning. Instead, the site seems to have developed an organic modular arrangement through the repetition of similar structures. Mud brick buildings were densely packed in a close-knit fabric that did not allow for the presence of streets and significant open areas. This at least until the end, the latest, the most recent layers. So this table shows the system or level that form the relative dating system of Çatalhöyük mound, establishing an overall chronological, an overall chronology of the site is made exceptionally hard by the steady development of occupation at Çatalhöyük, which unfolded without major breaks. While this is undoubtedly true, the CPR is engaged with a focused investigation of change through time. This effort has led to the appreciation of widespread changes to the site's occupation and to the recognition of a major break in the organization of the site around 6,500. Many lines of evidence converge to indicate an intensification of activity within the house, along with a divide between older modes of collective social organization and newer, more fragmented and dispersed social arrangements centered around houses that were increasingly autonomous unit of economic production. After almost 2 millennia since settled farming life took root in Central Anatolia, 6,500 BC is also considered the starting point for the expansion of the Neolithic lifeways into Western Anatolia. But which was the shape of Çatalhöyük community? How was the site organized? So at Çatalhöyük, everything appeared to be about the house. Houses at Çatalhöyük were the center of social life. They were both ritual spaces and main units of production and consumption. Through the materiality of the house and the rhythm of their construction, maintenance, and closure, people experienced concept of place and time and were tied together. Houses at Çatalhöyük were all similar entities, and one of the most striking features of the settlement is the repetition and continuity of its built environment. This distinctive material sameness corresponds with the social homogeneity. No clear indication of hierarchical arrangement of power and authority have ever been found at the site. Nevertheless, a vast array of evidence for horizontal differences and variation between buildings has been detected at the site since the first excavation carried out in 1960s. So for example, this is a map of level North G, and you can see that there are differences, for example, in size of buildings. Some are smaller, some are larger. Differences are evident even in ritual elaboration and number of burials within buildings. These differences, however, never translated into difference in rank or power or in the control of resources and production. So these differences have been variously explained through time. I will just summarize some of the main approaches. So in recent years, different models of social organization have been proposed. So I mentioned here just a few. So Harder and Pels, following Levi-Strauss, concept of house society, suggests the process of differentiation between ordinary houses and history houses through the accumulation of social memory. This social memory is materialized in symbolic elaboration. These houses then are regarded as focal nodes of extended affiliation networks. On the same line, Mills sees Çatalhöyük social fabric arranged in flexible networks of cross-cutting social groups that overlap to form a tightly knit society. Other scholars highlight the role of spatial proximity and clustered neighbors as the way the social fabric of the site was arranged. According to Düğümü, social association larger than the individual building materialized in relatively autonomous cluster of adjacent buildings that were sharing roofs. Most recent decay within a biographical framework has suggested a more fluid understanding of house structure at Çatalhöyük, and highlighted the dynamic nature of house, which it sees as crossed by different groups of people during different periods of the house span. Said this, I will again very briefly touch upon the methodology that I use. So what is network science and what is a network? So network methods represent a set of tools used across a wide range of disciplines that are rooted in different theoretical backgrounds. In the recent editorial, What is Network Science?, Branded and colleagues define network science as the study of the collection, management, analysis, interpretation, and presentation of relational data. The relational nature of these models is what really distinguishes them from other statistical models and other tools. And in this respect, it is important to stress that the concept of dependency among entities, nodes, ties, attributes, that constitutes the network system is central to all network approaches. The dependencies among parts are the place where relationality unfolds. So what is the network? The basic components of these network models are entities, variably defined as actors, nodes, vertices, or points. They are usually characterized by a series of qualities and relationships among them that are typically defined as ties, links, lines, or edges. These objects are for the most part, but not exclusively, represented as node links, diagrams, which are graphs made of points linked by lines, which are the ones that you're seeing now. A variety of mathematical, statistical, and computational tools have been developed across disciplines to model, interpret, and quantify the behavior of network systems. I would like to stress here that applying network perspective to archaeological observations is not trivial and requires a process of simplification and abstraction. Additionally, archaeological networks are not the result of direct observation of social phenomena, but always indirectly extracted from a series of material and spatial proxies to which social significance is ascribed. Data-driven archaeological networks, like the one constructed for the current research, are artifact networks, which are produced from the abstraction of material links. They are therefore always heterogeneous, composed of the interdependence of different entities, and they should be more precisely defined as socio-material. So, constructing network as Çatalhöyük. So, as already anticipated, nodes in the current studies, entities, nodes in the network are represented by individual buildings whose relationships to other buildings are established based on the repetition of specific material feature. Socio-material networks are thus traced through similarities between material culture. The selected buildings have been arranged in temporal groups, early, middle, and late. I would like to add here briefly an observation that the houses at Çatalhöyük are not are in any way unproblematic entities. And while they were clearly durable space in which the concern of the site's inhabitants for memory and time death are revealed through repetitive practice, buildings were also dynamic and developing structure. Houses went through different incarnations during their use life. For the majority of its history, households at Çatalhöyük were not autonomous or bounded units, and they are very difficult to determine. So the social groups are extremely difficult to determine. However, individual buildings at Çatalhöyük have been chosen as the major system entities because they are the key component of the social fabric, and despite differences and changes through time, they represent the main and enduring principle of social organization. The house, therefore, with its location in the landscape and the material associated with it, offers the necessary link for network modeling. Thus, it is the materiality, speciality, historicity, and specificity of buildings that make them appropriate analytical unit at the site. So links. Links between buildings, nodes, are established using a number of material attributes, and they were selected from a vast array of diverse artifact categories, including, among others, specific architectural features like the location of benches, the location and type of oven, location of the platform with the largest concentration of burials, location and type of mural paintings, animal installation, type and location of burials, obsidian artifacts, location and source, specific items like macettes in burials, items of personal adornment, and botanical remains. In this case, the idea of using a selection of different datasets belonging to a variety of material classes to trace link between buildings is rooted in the conviction that at Çatalhöyük, using different material classes together in a sort of flat, non-hierarchical way has the advantage of avoiding dichotomizing the dataset between, for instance, retail and domestic or private and public. So I'm going to go super quickly through the most technical parts. I just state that here that these are the results. These are the network that I constructed. I used mainly two different types of networks, the two-mode network on the left, and projected weighted one-mode network, projected network of building, and projected network of objects. And as a way of studying the obtained network, I integrated a selected of analytical tool chosen from the entire network science methodological tool. I use exploratory modeling and validating exploratory modeling validated approaches together. I use centrality measure, grouping techniques, modeling like regression techniques, and I largely use permutations and assortativity as a validation tool, as validation tools. Okay, I will now move to the results. So networks have been created, as I said, for different chronological slices. I'm not gonna have a lot of time. I'm just gonna show them to you because I really don't have time to get into the details. So you see, these are the early period. This is the early period, the middle period, and the late period. Instead, I'm gonna jump to a main overview of some of the main trends that this analysis highlighted. So the network approach allowed me to make some observation, and I will now quickly illustrate the results focusing on two main aspects. Their development through time, which I interpret through the lens of a progressive process of community identity formation. And I will then discuss the spatial distribution of the results, focusing on the role of spatial proximity as a principle of social organization. So when looking at the results diachronically, they suggest that building networks grow bigger, more unbalanced over time. The middle network, which is the green one in the middle, emerges less flat than the early network, more tightly organized around focal nodes and uneven in distribution of distances between nodes. The middle network shows as well a very high interconnection. However, the increase in connectivity is strongly related to the presence of a group of buildings that share a high amount of material feature and are therefore highly interconnected. The middle network of buildings, therefore, strongly characterized by a group of very prominent central buildings that are this group here in the center. What also defines the middle network is the density, which is the highest of the three constructed networks. And moreover, the network configuration corresponds with a general increase from the early to the middle in material homogeneity that nevertheless doesn't eliminate a degree of diversity and heterogeneity or materials choices of the individual building. Each house was able to maintain an amount of flexibility and independence amidst the density of ties. So what appears to be unfolding here from the early to the middle periods is a process of community construction and identity formation. The early network is made of buildings that can be defined as a mosaic of distinctive identities shared by a group of buildings. And the servo-homogenization process fits well with the idea of Çatalhöyük and other large Neolithic agglomeration being a community born to keep together multiple identities. The network configuration suggests that this process of homogenization and identity formation happened through the mediation of highly interconnected buildings. So if we look at the, in terms of changes through space, the modularity maximization analysis performed on the free network of buildings has highlighted a modularity partition based essentially on geographical proximity. Buildings that are geographically adjacent are embedded in dense set of material connection that differentiate them from other group of neighboring buildings. Buildings that are close to each other in space are more similar in terms of material assemblages and are therefore more intensely connected in the network. This is particularly evident in the middle network, given its larger geographical extent that comprise both the north and the south area. The analysis highlighted group of buildings mainly centered in the south, like this. The groups are color coded. So there is this purple group mainly centered in the south. And of course, groups centered in the north, like the green one, for instance. And this is as well seems to confirm sort of difference that has been observed previously between the north and the south area of the site. So, it should also stress that some of the adjacent buildings that cluster in the same algorithmically defined community, so in the same group that you see color-coded, are not contemporary. This is the case, for example, of Building 131, Building 77, 132, Building 1 and Building 3. So the result of the network community detection analysis doesn't seem to point to a tightly clustered neighborhood shape of the town or the site. And it may reveal a more sparse and flexible habitation pattern that was, however, deeply committed to place, and I would say to the returning to the same place. Additionally, the diachronic spatial clustering that I see has recently been observed. Okay, so additionally, this kind of diachronic clustering, clustering of buildings that are not contemporary has been observed recently using isotopic analysis of human diet. And in a similar vein, recent archaeobotanical research has further highlighted similarities in land use by neighboring building or by building in the same sector of the East Mall that are observed across time periods, so they're not necessarily contemporary. So if we consider the recent archaeobotanical evidence, a model of land management arranged in radius slices of arable land around the site has been proposed. According to this model, spatially proximate building on site were exploiting the same wedge of field radiating from the mound into the surrounding landscape. So the location of the building in a specific sector of the East Mound may have entailed a complex set of relationships with the landscape and with the people, things and localities within and beyond the site at different scale. The spatial proximate groups of building highlighted by the network analysis might show this set of complex relations that were shared and inherited by buildings occupying the same portion of the site. It should be said, however, that geographical proximity, if we go back to this, geographical proximity accounts for only a part of the behavior of the network data set. And some links between buildings cross-cut their geographical location. Even if different clusters of spatial contiguous buildings have been noted, the entire community of Çatalhöyük maintain a distinctive identity through its life by means of what appear to be strong social religious rule. The long distance ties were probably of major importance in maintaining the coherent and distinctive identity of Çatalhöyük community. which was very likely essential for a long existence of these communities. You see, for example, here that building 50, it clusters with all the north buildings in the north in the green group, or 96 cluster with the orange, 102 with this group of building in the south. So there was something else on top of the spatial location that was modeling the social reality of the site. So what appears to emerge from the network analysis is a flexible, multi-level system that mixes a focus on geographical proximity as a tool of shaping social association with a connectivity that also incorporates cross-cutting ties over greater distance and over time. So, and we could talk about a sort of internal structure composed of nested membership in different groups based on proximity and another principle. And this may have been very useful in facilitating the contemporary proliferation of different and even redundant tradition and promote flexibility and resilience within the system. And this seems to be very clear in the botanical remains, with different buildings, with the decision making at the level of the buildings and groups groups of building on which kind of crop to use. Okay.
Sorry, Camilla, we are around the time. Could you please conclude?
Yeah, I'm concluding. So I'm not going to show you this. Okay, just brief couple of points. So, so this study was able to highlight a dynamic social arrangement characterized by change and experimentation that allowed for different, probably competing contemporary tradition, a social fabric that was very likely made of nesting sets of affiliations, starting from groups of close-by buildings that were probably sharing the same portion of the landscape, but that included cross-cutting ties, a process of community identity formation that happened through the mediation of prominent buildings that acted as hubs of relation between houses, and a system that for a long time managed to balance homogeneity and differences between its components. Again, an egalitarian system where what appears to be equalized, at least until the late period, is the use of the landscape. So, thank you very much.